Okay, so to manage populations successfully, you need to do head counts, but also you need reproduction rates. It's important for pinnipeds in general and for eared seals in particular, because they have the highest reproductive contribution among the mammals. And the variable history strategy shows that nutritional energy is redistributed by females on reproduction and survival. And the rate of this distribution aligns with RK selection. I spoke about it in 2016 in Astrakhan. It's important, though, to observe fur seal females throughout their life cycle so that we can see when they became active reproductively, when they stopped reproducing, what's the frequency, so that we can at least give an estimate to the quality and quantity of pups that one female would give birth to over her life cycle. It is possible by means of large-scale tagging and recapture. It is possible to obtain this data on the Commander Islands, but then you need to analyze it, which is a bit of a challenge. Here are the stats for our tag capture. We began with an observation post in 1972 in one of the Commander locations. It went through to 2014. But there are certain limitations with this method. We cannot be fully sure that unobserved females didn't visit the rookery. The probability of capturing a tag is about 50% though for all females there. As we do these scans every day, and this goes on for about a month and a half, then the general probability goes up. Then, as you extend it over the years, the probability goes up even further. But then again, there is still some margin for omission. Tag loss is under research. As you will know, these are metal tags that can get lost, unlike branding. Alexey Altykhov gave a very interesting presentation, and it was mentioned there. Then this also doesn't account for female migration to different rookeries. However, this is a minor effect. If these limitations are lifted, though, then corrections can be or should be done to the evaluation of the overall parameters. This shouldn't affect the trends, however, that we have identified, so I'll present them with pleasure now. The results can be presented in two key tables, a table for females and a similar table for pups. Column 1 shows the first visit of the rookery by a female and then subsequent visits. The first line shows the number of females originally observed at the rookery at a given age. The column before last, to the right, shows total observation. So this total of 3,208 females in that first line is the total observation of tagged females there. The last column shows the number of pups that were born during the second and 17th reproductive seasons. The line before last in the bottom shows the total number of tagged females that visited the rookery for a given age, and the last line, as well as the picture in the next slide, shows the data for the number of pups that were birthed by tagged females over different ages. And the following slides give some meat to this bone, and these are better visuals. This chart is the share of distribution of births by females of different ages. So you have 5 pups by females covered at year of 2. And these are the relative values, whereas the table would give you actual numbers. Reproduction stops by about 22 years of age. A couple of pups born there, and after, the birth rate would be just about 1. Here are the data on repeat visits by females in the following reproductive seasons. We have season 1, when they gave birth to pups, and the percentage goes down gradually after. Chart to the left shows the number of pups born depending on the number of rookery visits. Unfortunately, this presentation wasn't provided ahead. I'll ask for the slides to be published, but let me continue, otherwise I'll not have enough time. There is a comparison of birth rates over the years for the observed females. Observations began in 1982. And we can extend it back a bit to 1979, because these are 3 years of age. And before that, we hadn't tracked females for the entire life cycle. So the older individuals would have been observed for shorter periods of time. In 1970s, the birth rate was high, even without the metadata. In the 80s then, we saw the birth rate go down, even though all fur seals were accounted for. We saw some variation after, going into the 90s, but it might have to do with the number of tagged fur seals being fewer, because branding wasn't done then. This is a slide presenting the same data, but it's a table presentation. So you can see birth rates for each decade. You see that the number of females who gave birth to 10 pups is low. You have 60% with 1 pup, 19% with 2 pups, and so on and so forth. This slide shows the number of females going to reproduce on the rookery depending on the age of their first visit. we calculated this for the generation of 1979, 1997, and the age of first sighting would vary between 1 years of age to 19 years of age, peaking at 5 years of age. Out of these generations between 1979 and 97, about 40% was sighted only during one mating period. And we didn't see pup mortality there, so we don't know what happened to these females after. If females visited rookeries 2 or more times, that would be 2 or more reproductive seasons, the value would be 52.8. That is percent. And the visits were done at 3 to 6 years, and 6 to 10 would be 32%, and over 10 years, this would be 6.8%. This slide shows our calculations for the same set of generations, 1979 to 1997. It's a calculation of the number of pups born by a female within her life cycle. We factored in tag loss and we assumed 0.5 probability for sighting that female on a rookery. If we propagate this for all females, then the average number of pups born versus the total head count of females would give you about 3 pups per female. If you think about the females that were sighted just once, if you factor in 3 sightings, then the ratio is going to be 5.6. This is the matrix that represents the number of pups born for each subsequent rookery visit, depending on the age and on the first sighting at the rookery. So this could be taken as the reproductive maturation age, except for individuals that are 1 or 2 years old. This table requires a bit more time, but a brief explanation is this. We cited a total of 167 females in the category 2 years of age. Only 5 gave birth to a pup at the age of 3. 3 females in the age of 4, 11 for 5, and so on. So the total number of pups was 82. 2 or more visits was 84. And the total sightings would be 372 for 164 females in total. So that would be females that went to reproduce from 1 to 18 years of age. So for the year 18, we would have 2 females, 2 sightings with no pups. Here is the aggregate of the data from that previous table. So females going to mate for the first time when they are 3 to 6 years of age. have about 75% reproductive success. Or rather, they account for 75% of the young of the year. Then you have females going out at 7 to 10. They give another 15%, and the remainder of the females gives the rest of the 10%. Now, here are the conclusions. You can see that a large share of tagged females were sighted at the rookery only within one reproductive season. That's something that requires further investigation. We need to see what happened. Some died, some lost their tags, others could have migrated. But that's the effect, and we need to decompose it. 41.6% of the total sighted tagged females gave birth. Only 2 females gave birth to 10 pups over their life cycle, whereas 60% of females gave birth to just 1 pup. Only 5 births were observed in females of 3 years of age. More births are given at the age of 4 and continues through to the age of 22. The first visit to the rookery varies from 1 to 18 years of age. Where we have resightings, 2 and more observations over 2 or more reproductive seasons, we would have 52.8% of the individuals visiting the rookery for the first time between 3 and 5 years of age, 32.1% when they were aged 6 to 10, 6.8% at the age of 10 or more, or there is an additional 8.3% that went to the rookery for the first time when they were 1 or 2 years of age. Best reproductive performance is given by the females that first visit the rookery at 3 to 6 years of age. The average birth rate that was calculated using the demographic techniques for humans would be 3 pups as a ratio to total tagged females and 5.6 pups as a ratio to females that are resighted. With that, thank you. Did you factor in misidentified tags, and did you verify that observations were correct? Yes, we factored that in. So all tags that were observed only once during one reproductive season were discarded from the database. We used only the data for females that were sighted several times during one reproductive season on the rookery. So that would be, so if part of the tag was not legible and a recite didn't give you a confirmation, then these were discarded as well.
Right, the next question is about the influence of the numbers of male animals, those who were mating with females after the harems dissolved. This was an important. That's why there are these longer periods for females over 10-year-old. So probably young females come to this rookery at the age of 1 or 2 years old, and they come in August after these harems dissolve. Yeah, they come to the areas where single males stay, and yes, then these females are raped. Yeah, and that is why they become pregnant and have pups at this age. But physically, they are still quite weak. So 2-year-olds, they are similar to animals below the age of 1. So they are like juvenile animals, and there's not enough energy, and a physical condition is not appropriate for a positive outcome of the pregnancy. And the reproductive cycle is violated. This was actually described in the 1960s. Yeah, so it was the Pribilov Islands survey in the 60s. And then for a number of years, these females, they do not reproduce. So, and it can be for as long as 10 years. Because there might be different damages to their bodies, okay, aborted fetuses, and so on. In the 1970s, when there were a few bachelor animals, and at the same time there was that spike in the birth rate. Yeah, so this is what I was showing to you. Yes, this one. You see in this period, can you see it? Yeah, can you see my slide? Yes, yes, we can see it. So during this period, there were no bachelor males, and then the females at the age of 3 or 4, okay, they used to come to this rookery, and then they gave birth 1 year later. Yeah, so this was important for this age group. So I believe that it was related to this factor. So did I answer your question? Yes, thank you very much. Thank you. And one more question to Vladimir Burkanov. So what about the probability of the number of birth rates during the 18-year period? Well, we didn't study the probability rates. So we have done some preliminary work. We do have a database for one island and for Northwest Rookery, but we don't have yet data that when females come to these rookeries at the age of 10, we don't know whether previously they had been observed somewhere else. We know from the literature that there is migration from one rookery to another, and usually it happens up to the age of 4 or 5. And usually animals, females, if they had a pup on one rookery, they stay in the same rookery for the rest of their life. So it's hard to say. We don't know whether we don't have any proof that these females had given birth somewhere else before this age. So right now, there's not 100% certainty that when these females come to the rookery at the age of 10, that they haven't had any births before. This is something that should be studied in the future. We need more serious work and greater detailed surveys to resolve all this, yeah, and we need to eliminate this uncertainty. So this is just the first, this is just my first presentation, and this is the first attempt of analysis of all the data which we have accumulated, and we were using these metal tags for animals.